Melinda Wetzel. This is Crash Course Nuclear Energy, and today we are going to be talking about how nuclear energy affects climate change and what we can do to fix it.
So isn't nuclear stuff that goes boom, boom, pow, kabam?
No.
Then is it when you stand by your microwave for too long and it cooks you with radiation?
No.
Is it when you drink dirty water and it has radioactive stuff and you die?
No.
Ooh, is it when?
Let me stop you right there. The answer is no. Now, in order to explain how the world could change with nuclear energy, maybe I should actually tell you what this whole nuclear radioactive fission reaction thing is and how it came to be. Let's go back in time to 1895 with something that we now know as the X-ray. Wilhelm Röntgen was casually performing experiments on a covered photographic plate, as one does, when a high voltage discharge tube accidentally got exposed to radiation, and voila, the X-ray was invented. Now, one common theme I have found in scientists is cool hair, cool names, and the fact that they always make discoveries accidentally. Newton sat under a tree, an apple fell, and gravity was discovered. Amazing. A year after that, a man by the name of Henry Becquerel attempted to induce X-ray fluorescence into a uranium phosphorus using sunlight. By doing this, Becquerel discovered radioactivity. Now, what is radioactivity? It is...
Ooh, Miss Wetzel, is it when you drink spoiled milk and you get a tummy ache?
No.
Is it when you use too many Splendas in your coffee and die?
No.
Is it when you touch a power line and get zapped?
No.
Is it when a raccoon bites you and your mouth gets all fizzy?
No. It is the disintegration of unstable nuclei of atoms. After our friend Henry Becquerel discovered this whole radioactivity thing, scientists did anything in their power to understand it by trying to apply it to physics, chemistry, biology, and medicine. Sounds really confusing now, but I promise I will explain it. On our little nuclear journey, we passed Pierre Curie and Maria Sklodowska-Curie, who discovered polonium and radium when trying to separate chemical elements responsible for radioactivity. Also, Ernest Rutherford used his gold foil experiment to discover the nuclear atom, or a small positively charged nucleus surrounded by negatively charged electrons. This discovery changed science forever, as we now knew what an atom truly was.
Bruh, you make that sound so cool. I do it all the time.
Who let this kid in here? A few more advances came along with James Chadwick discovering the neutron in 1932 when alpha particle radiation on beryllium caused a nuclear reaction that emitted nucleons with no charge. In 1939, medium-weight atoms were produced for the creation of new chemical elements, which were the result of irradiating, or exposing to radiation, uranium with neutrons. At this time, nuclear advances were being applied to new technologies and discoveries. Now, the moment you have all been waiting for, the most exciting thing in the world, the discovery of fission, or splitting, of the nuclei of an atom. Woo! In this case, the atom was uranium, and the discovery of nuclear fission was by Lise Meitner, Otto Hahn, and Fritz Strassmann. This is very important because a fission reaction releases energy, neutrons, and other forms of radiation along with the decay of heat.
Bruh, I probably release more heat than that thing because I'm just so hot.
Wow, that was a lot of information to take in at once. Let me give you a break. Just kidding. Science. Oh, come on, don't give me that look. You clicked on the video. There are 3 types of starter Pokemon: Bulbasaur, Charmander, and Squirtle. Wait, shoot, wrong script. There are 3 types of radiation: alpha, beta, and gamma. Radiation can be split into 2 classifications based on the ability to take an electron from an atom or molecule in order to form an ion. The 2 classifications are ionizing and non-ionizing. Non-ionizing is low-energy protons of light as well as electromagnetic radio waves.
Bro, that is so important. I need radio waves in my sick beat. Check them out on SoundCloud, dudes.
Ionizing is produced by a beam of electrons hitting a target or by cosmic radiation, which both releases particles and energetic photons, which include gamma rays and X-rays. Ionizing radiation penetrates living organisms, alters cells, causing the cells to send signals to start a defensive response. It basically just makes your cells whip out their black belts and roundhouse kick out the bad stuff. In order to start a nuclear reaction, a radioactive material is needed. Uranium has 3 isotopes, or atoms with different amounts of neutrons, which are uranium-234, 235, and 238. Uranium-235 is the only one used for nuclear reactions because it is radioactive, meaning that the nucleus is unstable. The atoms split and then the nuclei break and neutrons, positive particles in the nucleus of an atom, are released. Uranium-238 can be turned into another element, plutonium. Plutonium-239 is radioactive, just like uranium-235. Both plutonium and uranium are found in a nuclear reactor. Here's the tea. Pause it. I have to start. Here's the tea. In a nuclear reactor, uranium-235 and plutonium-239 atoms split through fission, creating heat energy. Heat energy is then used to turn boiling water into steam. The steam turns turbines, and this produces electricity. Rods can slow down or accelerate this reaction by controlling fission rates. Uranium dioxide forms fuel assemblies through the manufacturing of pellets. Each one of these nuclear fission reactions releases 200 million electron volts. Let's do some math. This is more than 100 million times the amount that a combustion reaction and more than 10 times the energy released in hydrogen fusion can make. Wow, that was a mouthful. Nuclear energy is surprisingly one of the most clean energy forms, for there are no carbon emissions and the water used is recycled. Like every energy source, there are some negatives to nuclear energy. Many fear the potential release of radioactivity. There's a possibility that a nuclear incident, for example, Chernobyl, could kill hundreds. There's no such thing as a harmless exposure to radioactivity, but it is rare for it to cause health problems, although many hear fake news about cell damage. Some environmentalists fear the effect on living organisms, but not all. If you've seen any sci-fi movies, you know what I'm talking about. They always put mutated animals in them. It's really creepy, and I don't blame you for being scared. Look at Scooby-Doo. He's a talking dog that can solve mysteries. Or Clifford the Big Red Dog. He's bigger than this guy's ego.
Hey, bro, leave me alone.
Nuclear energy may also increase the risk of nuclear weapon proliferation. On terms of cost, in the 1960s, the cost was $1,500 per kilowatt. However, if many nuclear reactors are built, it is expected to be $2,500. This may be greater than the amount of coal-burning plants, but operating costs are low due to low costs in nuclear energy. The value of the energy over the lifetime of the nuclear plants, which lasts anywhere between 60 and 100 years, exceeds the amount of money that is invested. Mainly, people are making hyperbolized accusations about economy, sustainability, reactor safety, accidents, management of used fuel, radioactive waste, and weapons. Nuclear energy is our future. That is, if you want a good future. Unlike this guy.
Hey, what was that for?
Let's take a look at a few other energy sources to compare, because everyone loves a good T-chart. First, coal and hydrocarbons. While this source has an abundant supply, it's reliable for a large amount of energy, and it's fairly inexpensive, it does have negatives as well. This source causes pollution, carbon emissions into the atmosphere, danger to miners, a lack of air quality leading to health problems, acid rain, and environmental impacts that are being checked out in order to develop cleaner technology. Petroleum is cheap, easy to transport, and is a base to many products. However, this source has high carbon dioxide emissions. The supply is exhausted, it has a large environmental impact, and the prices are rising.
Isn't petroleum that stuff that you put on your lips when they get chapped?
You mean Vaseline? I'm talking about petroleum, as in the oil. Wind energy seems so safe, right? It has no emissions, it's cost-friendly, it has a high output, and the disruption of nature is minimal. Not perfect. The output relies fully on Mother Nature, and if she feels like making her lovely wind speed high. Not all geographic locations work with wind energy due to a lack of wind. Windmills take up a lot of land, and there's high investment and maintenance costs. Next, the sun. The sun causes no pollution, and solar power systems can last 15 to 30 years. Also, this resource is abundant. Wait, that can't be right. Aren't we supposed to blow up in 7.5 billion years? Gosh, that's not abundant enough. Solar power has a high initial investment. It relies on sunny weather, causing other energy sources to have to be found for areas with less sunshine. It takes up a lot of space, and there's a limited amount of polysilicon left in the world, which is what we use to make solar panels. Finally, hydropower. Hydropower has no emissions, and it's reliable. It makes large amounts of power, and the output meets its demand. This seems like a good option, however, dam areas are affected. It's expected, and droughts affect the dams highly. Overall, nuclear power is the most efficient and eco-friendly energy source. It does have some downsides, but they are just possible downsides. If we live in a world with nuclear energy, we can save our environment and live 7.5 billion years more, until the sun explodes and kills us all. Woohoo! Most rumors about nuclear energy come from the health effects. They say things like the kid in the corner over there say.
Miss Wetzel, if you stand by a microwave, you'll die. If you're within 1,000 miles of a nuclear energy plant, you will die. You will get cancer if you even say the word nuclear. Shoot! Nuclear power will cause your animals to become skeletons. Not even a nuclear vaccine can help you.
Ugh, no child. People are exposed to radiation every day. Radioactive release would most likely release low doses of energy, which are not harmful. In fact, low doses of radioactivity can be beneficial through the body's response to the stresses that are introduced. The average natural radiation dose rate is 2.4 MSV. On terms of accidents, they are possible, but rare due to a large and experienced staff keeping watch. It's important to communicate health effects because some fear cancers such as thyroid cancer, which are possible with large amounts of radiation poisoning. However, that is very rare and there's no real risk. Overall, the hyperbole and exaggerations that you have been hearing are most likely wrong, and nuclear energy is very safe. I've been talking a lot about science, benefits, and downfalls of nuclear power, but how do we already use it? Nuclear energy currently makes up 11% of the world's energy. We have used radiation for over a century, and we have used reactors for 6 decades. Nuclear energy has a lot of militaristic uses. In World War II, the Manhattan Project separated uranium-235, remember, an isotope of uranium, from natural uranium. Also, scientists found out that the isotope uranium-238 could be turned into plutonium-239, which, as I have mentioned, is also radioactive and can be used for these purposes. Nagasaki and Hiroshima were destroyed during World War II by 2 different bombs, one of which used plutonium-239 and one that used uranium-235. The USSR and many countries test nuclear weapons, and in the past this caused the arms race, or Cold War, that caused the release of bombs to go from 20 kilotons to 50 megatons of TNT. Many tests by the USA and the USSR occur in the atmosphere in order to make bombs designed for certain occasions that perform flawlessly. Captain Hyman Rickover came up with the idea of using nuclear reactor energy in the U.S. Navy shortly after World War II. This caused the start of the building of the USS Nautilus to start in August of 1950. It was finished in January of 1955 with complete nuclear power. Now we have hundreds of nuclear-powered naval vessels. Next, nuclear power plants started to be constructed. In 1956, the Calder plant was created in the UK. In 1957, the U.S. had commercial plants at a shipping plant. We have 500 nuclear power reactors in operation throughout 32 countries. In most of the 32 countries, nuclear energy is a great fraction of the electricity used for domestic service and industrial application. More than 440 nuclear reactors are in operation, with some nuclear reactors made just for plutonium-239. To make sure that nuclear energy was used safely, the Atoms for Peace Conference was held in 1955. The International Atomic Energy Authority was created to promote nuclear technologies and power plants for safe nuclear use. Without changing our current energy sources, we are in major trouble. Come on, guys, don't you want your great-great-great-grandchildren times 10 to the 100th to see the Earth explode? Our global temperature has risen 1.62 degrees Fahrenheit since the late 19th century. The 5 most warm years on record took place after 2012. The warmest year on record was 2016, with 8 out of 12 of the months being the warmest months in history. People, our oceans are warming. The top 700 meters of our oceans have warmed 0.4 degrees since 1969. Our ice sheets are shrinking. Greenland lost about 127 billion tons of ice per year between 1993 and 2016. The rate that Antarctica has lost ice masses has tripled in the last decade. Glacial retreat happens daily. We are getting less snow. Spring snow cover in the northern hemisphere decreased over the past 5 decades, and the snow is melting earlier. I know you may hate shoveling or getting snow to your cracks, but this is a problem. I want you to close your eyes and imagine this. You're sledding with your children or siblings or friends because it's a snow day. It's cold, but the white snow is glistening. Someone throws a snowball at you. Actually, I threw the snowball. And then an innocent snowball fight happens. You build a fort, you get cold, the sun starts to set, then you go inside to get hot cocoa with the little baby marshmallows, and you cuddle up and watch a movie. Wake up. Wasn't that amazing? Well, guess what? At this rate, enjoy it while it lasts because it's disappearing more and more every year. Our sea levels have increased 8 inches in the last century, and it accelerates every year in the last 2 decades. The rate has doubled the last century. Our ocean is turning into acid. Yes, acid. Since the Industrial Revolution, ocean acidity has increased 30%. This is due to you humans releasing all of your precious CO2 into the atmosphere, which falls into the ocean. Maybe if you would stop cutting down our trees, we would have more oxygen instead. By 2030, the demand of global energy is predicted to increase by 50%. Let's do some math. That's about 2.4% per year. This needs to stop. I agree, Bill Nye agrees, and you should agree too. How can you help? Let me tell you. Prevent the use of coal and hydrocarbon combustion, which currently makes up 88.6% of the world's energy. Let's educate about nuclear energy. Not many know about it. Let's start teaching the youth about climate change. Let's reduce water usage. When you are brushing your teeth, turn off the water. Use less electricity, turn off your lights. And if you crash into something, that's what Life Alert's for. Avoid the use of plastic. We're killing turtles. Turtles! Drive less, bike more. Saves the world. If this didn't inform you enough, read more into it. As a team, we need to convince others to live greener lifestyles. You may not be able to fix climate change on your own, but you can be the part of the world that helps because any action can help. Reversing climate change comes from everyone, including you. Using more nuclear energy in the world, we can prevent furthering these atrocities that are occurring as we speak. Thank you so much for watching. I'm Melinda Wetzel, and I will see you next week.
Atrocities.
Atrocities.
Atrocity. A-T-R.
8 atrocities.
At-
Wait.
the word is atrocity.
What? How do you say it?
City.
City.
Atrocity.
Atrocities. Atrocities. Atrocities.
Atrocity.
Atrocities.
It's like if atro was an adjective, you'd be like, oh, that's atrocity.
Okay, I got it. I'm ready. Here's the T. Start over. I choked.
What?
Atrocities.
Atrocity.
Further, we can prevent furthering these atrocities. Okay. Thank you, servant.
Ready?